Hello, Math 142. We are going to do a few problems. We're going to convert some equation from rectangular form, regular form that we know, to polar form. These problems are coming directly from your textbook, so I have to give credit to Stewart, Redlin, and Watson. Let's start with x equals y, which is the same as saying y equals x. That was probably the very first linear equation that you were exposed to. And the graph of that is going to look like this. So this is x and this is y, and x equals y is going to look something like this. Okay. Now, how would we show this in polar form? What is it that I know about x? I know x is r cosine of theta. So I have equal sign, and y is r sine of theta. So x and y. And but I also know that when x and y are equal, then tangent of theta must equal 1. Why is that? Because by definition, tangent is sine over cosine of theta. And if sine of theta equals cosine of theta, then tangent must be 1. And so my theta equals pi over 4, where sine and cosine are the same. They have the same value, I should say. And as you can see, it's very consistent with my Cartesian coordinate. Theta equals pi over 4. Okay, let's do another one. Suppose we have x to the second plus y to the second equals 9. Okay, so you probably remember this as a circle with radius of 3. And the center at the origin. So let's say if this is my x and this is y, and 1 and 2 and 3, and 1 and 2 and 3, and 1 and 2 and 3, and 1 and 2 and 3. And so, of course, you don't have to do the picture. I just want to show you some details in here. And let's just convert this to polar coordinate and see if this is consistent. X is r cosine of theta, quantity squared, plus y is y r sine of theta, r sine of theta, quantity squared equals 9. And this is the same as saying r squared cosine squared of theta plus r squared sine squared of theta equals 9. And notice I can factor out r squared, so that gives me r squared cosine squared of theta plus sine squared of theta equals 9. And cosine squared of theta plus sine squared of theta is 1. Okay, so r squared equals 9, so r equals 3. So notice that it is very consistent with the Cartesian coordinate. Let's do a couple more converting to polar coordinate. Suppose we have something as easy as, let's say, y equals 3. Okay, what do I know about y? I know y is r sine of theta equals 3. What can I do? I can divide both sides by sine of theta. So I have r equals 3 over sine of theta. And I can rewrite this as r equals 3 times 1 over sine of theta. What is sine of theta? It's cosecant. So r equals 3 cosecant of theta. And let's do one last problem of this type. How about something as, how about this one? How about x squared minus y squared equals 1? Okay. And of course, I don't think most of you haven't studied hyperbolas yet. This is a hyperbola with, yeah, let's forget what it is. We haven't covered that, at least in this class. So let's convert that to polar form. First of all, this x right here is r cosine of theta to the second power minus y is r sine of theta to the second power equals 1. And this is the same as saying r squared cosine squared of theta minus r squared sine squared of theta equals 1. And I'm going to go ahead and factor r squared. So I have r squared cosine squared of theta minus sine squared of theta equals 1. And I know that cosine squared of theta minus sine squared of theta is cosine of 2 theta. So r squared cosine of 2 theta equals 1. Okay. So r squared equals 1 over cosine of 2 theta. And one last baby step, I'm going to rewrite this as r squared 1 over cosine is secant. So secant of 2 theta. And that's good enough. I'm going to go ahead and stop there. I will do another video on converting polar to Cartesian, but I'm going to stop at here. I hope you find these examples helpful. Thanks.